In this section, we'll talk about the primary types of machine learning. There's three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, our objective is to predict a target variable given a set of observations. We accomplish two primary tasks. One is classification, or recognizing a category or class of an object. The second is called regression, or predicting some sort of numerical variable, such as the price of a home for sale. In supervised learning, we generally have a large set of past observational data to use for training, as well as the associated target variable for each of those observations. So examples of supervised learning would be using X-ray images to identify pneumonia in the lungs, or predicting real estate prices. In unsupervised learning, our objective is a little bit different. Here we're organizing data by some sort of inherent structure. We generally have a set of observations from the past available to us, but we don't have the associated target variables for each of those observations. So common types of unsupervised learning would be clustering or anomaly detection, and it's used for things such as market segmentation, where there are no commonly agreed upon definitions of market segments, but our objective is to take the potential buyers or customers for a certain product and break them into logical groups based on some sort of inherent pattern or order in those customers. The third type of machine learning is called reinforcement learning. Here our objective is to learn a certain strategy through interaction or achieve a goal. This is the type of machine learning that's often used to teach computers to train, to learn how to play things like chess or checkers. We'll now dive in a little bit deeper on supervised versus unsupervised learning. In supervised learning, we have some set of past observations of the features, and we have the associated target for each of those observations. We can use those to develop a model. So let's say we want to build a model to recognize apples. We have a set of pictures of apples, and for each of those pictures, we have a label that says this is an apple. We build a model using that set of pictures of apples, and then our model is now capable to recognize new pictures of apples. So we can feed it a picture of a different apple, and it should be able to recognize that this is also, in fact, an apple. In unsupervised learning, we have observations, but we generally don't have target values which are associated with those observations. So keeping with our fruit example, here we might provide a large set of pictures of different types of fruits to our model. Our model would then be able to organize or group those fruits based on some sort of inherent pattern or structure. It might use color or shape, for example, to separate the apples from the oranges from the bananas. But it wouldn't necessarily know that these are apples or these are bananas because we've not provided the target information for each of the observations to be able to learn that target. Our objective, again, is different. We're trying to group or organize things, not predict a specific output target. There are two primary types of supervised learning: regression and classification. In regression, our objective is to predict some numerical target variable. So we've talked about the example using home prices. Other types of regression might be used for things like predicting demand for a certain new product that's being launched, predicting power outages or demand for power over time, which all take numerical values. In classification, rather than predicting a continuous numerical value, we're predicting or identifying a class or category for a certain observation. Examples of this might be detecting lung diseases, identifying different types of plants or flowers, detecting whether an email message is a spam message or not a spam message. In all of these cases, we have a set of categories, which may be a binary, either yes or no, 1 or 0, or maybe one out of many possible categories, such as types of flowers. And our objective is to predict the category that a new input observation falls into.